Hello and welcome to Tech Gainers. My name is Chandra and I'm a technology explorer. In this video, we will see how you can secure your APIs. Basically, everyone talks about developing the APIs, developing using the Spring Boot, using Express, Flask, or any other frameworks. But no one generally talks about securing your APIs, which is the crude part of any API development or API journey. Let's see how we can secure your APIs using 5 ways. So you can see like 5 different ways. Our first one is our basic, second is API key, third is bearer token, and fourth is TLS MTLS. And fifth one, it is the most important, but no one talks about this, which is indirect security methods, which doesn't talk about any token, any API key, or any user credentials, but it is all about how indirectly you are securing your APIs from fraudsters. So first one, as you can see on the screen, is the basic security. It involves your base64 URL encoded username colon password. You are directly using your credentials, like as a user, my name is Chandra, so my user ID can be something like chandra.sharma colon and password, and then we will base64 URL encode it and pass in the authorization header with the value of basic with a space and that string base64 URL encoded string. And if your user ID password is correct, then API will be invoked successfully. So this is the very basic form of securing your APIs after API key. We'll see what API key is. So generally what happens when we give access to the APIs to the third parties. So to every third party, we give a very unique key, which is called as API key. It can be something like your UUID, or it can be any combination of strings, alphanumeric it can be. Okay, so now this can be passed into two ways, right? Generally we have seen either we passed it as a query param or we passed it as a header param. Okay, so for example, generally we use x hyphen API hyphen key. So in the query parameter, after question mark, we send it as x hyphen API hyphen key equal to my API key. And if the API key is correct, it's valid a key, then your API will be invoked successfully. Now next is the mostly used, it is called bearer token. So this itself called as the, like, who is the bearer of this token will allow the API access. Now this is passed under the authorization header with the bearer space the token, and token can be like two types of tokens are there. One is your opaque token and one is your JOT token. So opaque token, as the name itself says, right? So no one can directly distinguish like whether this token is for which customer or which user, and it can be known to the authorization server only. While the JOT tokens are the readable tokens. So if you go to like generally accessible jot.io, jwt.io website, you can decode that token and you can see the content of the token. Okay, so these are the two forms of tokens which we can use. And as on the screen you can see, right, authorization colon bearers space and the token value. So if your token is correct, right, then you will be able to access the APIs. So here in the indirect security methods, we will see how this bearer token will help us to achieve greater security of our APIs, and also how we can restrict the APIs to the legitimate users. For example, if I have given the access to my contacts, Gmail contacts, so ideally that token should allow only the contacts, not the my calendar or my Gmail or my drive. We'll talk about it. Next is your TLS, less mutual TLS layer. So TLS is transport layer security. So whenever you are sending some request, okay, so that request goes through a transport channel, and when you secure this channel, right, we used to have TLS. Previously it was called SSL. Now we have TLS, transport layer security, and current version is 1.3. So what will happen, it will secure your communication, right? You have used you have seen HTTPS in your browser, right? So that is the TLS. Okay, so it is saying that whenever the client is verifying the server, for example, your client is your browser, and when we give www.google.com, so what will happen? Browser will verify the certificates, whether this certificate belongs to that particular google.com only, and there will be a handshake would happen. Okay, so that is termed as TLS. Previously it was called SSL handshake. So again, this thing happens, but this is the way where the client verifies the server, and it happens through the certificate mechanism. Now we have seen that client is verifying the server. So other case can be whenever the server wants to verify the client, whether the client is a legitimate client or not. So this is termed as mutual TLS, or you can say bidirectional TLS, where both client and server are verifying each other. So this is the way that, for example, if I have given the access to third party called Paytm, right, then the server can verify whether the request is coming from Paytm or not. So this is how we are securing our API, so that no other third party which are not allowed can't access it. Now come the indirect security. Basically, this doesn't, you won't be able to see in the form of token or a query param or a header param or something like basic. So indirect security is whenever you are applying the security of the APIs at the behind the scenes. Okay, for example, first one is your quotas and throttling. So for example, if your token is stolen and someone, the fraudster is trying to call the API n number of times, but if your quotas and throttling are in place, then the fraudster won't be able to invoke the APIs. Only that particular number of times he can do that. Second, again, it is related to first one, which is called as bot detection. Fraudster has taken over the systems, right? And he is continuously stealing the token, right? So bot detection can help prevent this condition, where bot will identify whether the requests are coming from a legitimated thing. For example, if Paytm generally calls 20 requests per seconds, right? And if you are getting some 100 requests per second, then bot will identify that something is fishy here, and it will alert us. Third is your API gateway centralized management. So when we are talking about APIs, we are n number of APIs, right, in an organization. So what we can do, like we can have a centralized mechanism where all APIs are taken care by a central gateway. Okay, this way we can secure our APIs at a standard point. Okay, in a standard way we can do that. And if anything is like, if any security vulnerability is there, so instead of going through all the applications, we can handle it at a single place. Now fourth is your identifying the vulnerabilities. So what exactly this point is? For example, if you are using some third party open source applications or the systems or even the COTS products, right? So what you need to do is, at a regular interval of time, you need to see whether any active vulnerability is there or not. If some open source has released any kind of patch or something to handle that vulnerability. So this is important, because whenever you take the third party or the open source component, right, so in that scenario, all his problem, that particular open source problems, will come into your application as well. So it's your duty also to check at regular intervals whether any issues or not. Now the fifth one is fine grained authorization. So this is related to, again, bearer token. So for then, when I was talking about the Google contacts, so if the user has given the consent for contacts only, right, that means the scope is limited to contacts. Okay, so when we are saying fine grained authorization, that means, suppose you have hundreds of APIs, right, but only some 20 APIs are for admins. Okay, so there should be like a very well defined scope, and on that scope only the token should be issued. Okay, so for example, I am not having access to admin API, so ideally that token should not allow it. So this is how we are securing our APIs indirectly, right? So the user is legitimate, like I am allowed to access the Google APIs, But what all APIs? So that comes under the part of fine-grained authorization. Now, sixth point, which is not listed here, again it come to me as I am talking. So here is the IP whitelisting and blacklisting. So again, this is one of the most important part, because whenever you know, right, you know your third parties who are accessing your APIs, they have a limited set of IPs. So you should ideally do a whitelisting of IPs, and that particular IPs should be able to call your APIs. In this manner, you are restricting the traffic to a specific set of IPs only. This is all about securing your APIs. These are not limited to, like, either you need to use basic or you need to use API key, but you can have a combination. For example, first one is your API key. If API key is correct, then you are going to check the token, bearer token. Okay. Similarly, MTLS, it's up to you. You can apply MTLS in basic as well, API key as well, and bearer token. So you can have a mix and match of these security types, or how you can secure your APIs. This way you are kind of restricting the fraudsters. So I hope this has given you some idea. And in my further videos, so you can check out my Keycloak videos as well, which is a very good open source SSO, and as well as OpenID Connect and OAuth 2.0 provider. So you can see my videos for the implementation as well. And in this API security series, I will bring you hands-on for all these security types. You will see further videos on each and every topic. So if you like the videos, just subscribe the YouTube channel, and also please like the video if you like the content. Thanks a lot. I'll see you in the next video. Bye bye.